is the tools. So this so here is the torus. So this is the jet that is a gas clouded in this the line jets. So depending on where we are from. So for example, if you are here, so you cannot see. You can see the jets directly, the broad line of the jets. So we can see the Sy2 galaxy. So we can see from different part of places. So for example, if you come to here, so we cannot see the broad line. So because the obscure tour can affect in order not to see the center of the galaxies. This is supermassive black hole. So depending on the orientation that we have, we can divide it the type of AGNs. So we can say Sy2, the broad line can be seen. So Sy2, and even for radio galaxies, so around here, and even for radio loud quasars will be around here. So it is very important for us to know the orientation of the AGNs in the galaxies. So now we come to one of the basic things. So we call it BPT Diagnostic Diagrams. So this is in order to classify the spectral lines of the AGNs based on the spectral lines of this is, as you see, this is the BPT Diagnostic Diagram. So this is taken from the Kewley. So this is, as you see, the horizontal lines or x-axis is the logarithm of nitrogen to line H alpha versus to logarithm of oxygen for oxygen's line to H beta. So these lines, these regions are star-forming regions. So this the second one is, we call them the composite galaxies. Those are the galaxies that has some star formation rate and some will be some part of the AGNs. So the other left are, these sides are almost, we call them AGNs. So we divided AGN into two parties, Sy2 and LINERs. So even these lines are drawn from the Kewley 2006 and the Kaufman lines that was drawn, given by the different authors. So which is very important. So what I did was I used the SDSS DR8 spectroscopic and photometric data, and even I used redMaPPer DR8 galaxy clusters and the galaxy members, which is 25,236 clusters. And we use also the galaxy zoo, the morphological galaxy zoos. So then based on this one, I see the BPT classifications. So I try to have my samples, the AGN sample from the whole samples. So what I found is, first I check the probability to be a member of the galaxy members. So I divided the all AGNs, there's all samples into 3 redshifts. So when we say Z1, that means all redshifts. So when we say Z2, that means at low redshift up to 0.1, and this one is for high redshifts. So taking into account the probability to be a member of the galaxy clusters, so we found like 823 of them are AGNs, and from these ones, I found 187 of them are Sy2, and the rest are the LINERs, which is almost 77% or 636. So, but I want to check the population of the AGN after taking into account the probability to be a member of the galaxies. So then I check, after I check the probability to be a member of the galaxy. So I found lastly at all redshifts, the AGN was like 517, and this is for low redshift, and this one is for high redshift ranges. So at UC, most of the AGNs are founded at high redshift ranges. And from these AGNs, so most of them, like, you know, most of the mass comes from the LINERs, and 436 of them are LINERs, and 81 of them is Sy2. This is for taking into account in all redshift ranges. So when we divide it at low redshift and at high redshift, there was a big changes. So we found 26% or 21 of them are founded in low redshift and 60 of them are founded at high redshift. So here is also for LINERs, 141 of them is founded at low redshift, and this one's for high redshift ranges. So this one is, now I come to my results. So as I told you, I first choose the spectral classification like the BPT Diagnostic Diagram. So I did for each of them for nitrogen 2 lines and for oxygen 3 lines. So most of them, this is for the whole samples taking into account in all redshift, and this one is for low redshifts, and this one is for high redshifts. So as I see, most of them are founded in the AGN. Basically, LINERs are more founded, and few of them are safer. And this one is for composite galaxy. We can see the statistics, how does it look like. So I put on the last parts. So this one is for taking into account divided on the spectral classification based on the redshift ranges. For all redshift, for low redshift ranges, and this one is for high redshift ranges. And I choose, here is the statistics, which is I prefer to use the nitrogen 2 line of number of the galaxies. So which is 1,596 for all redshift, and this is for low redshift ranges, and this one's for high redshift ranges. So I did for the 3 of them, for nitrogen 2 line, for sulfur 2 line, and for oxygen first lines. So, but I when I compare all of them, so I have to prefer the number of the galaxy which is more highly. So I prefer to use the nitrogen 2 line, which is 1,596 number of galaxies. So then everything after now, I do all of the things based on this number of sources, which is the nitrogen 2 line of 6584, which is this number. So when I see, after I take into account all redshift 1,596 number of sources, so I try to classify them into different redshift ranges. Then I prefer to have the star-forming galaxies, then I have the composite galaxy, then I divide it to the AGNs and the safer and as well as the LINERs. So as you see from the statistics, so 140 of them is, this is the star-forming regions for all redshift ranges, and this is for low redshift range, this is for high redshift ranges. And I found, because my point is in order to select AGNs, so I select the AGNs, which is 823. So this one is my AGNs, and from this one, 187 of them are safer too, and the LINERs are 636. So this was my statistics. So this is from 823, of 259 of them are at low redshift, and this one at high redshift. I have more sources, you know, SDSS DR8, it was Sloan is a more complete up to 0.1, you know, number of one, you increase the number of sources. So as when you go to at high redshift, we will have observational biases and so on. So I think we lost so many sources at high redshift when we do analysis. So this is also the BPT Diagnostic Diagram. So in order to show you how I did for sulfur 2 lines with respect to oxygen 3 lines. So this is for the second one. So this is the star-forming region and the composites, and this is a safer, and this is a LINERs taking into account again in all redshift, and this is for low redshift, and this one is for high redshift. So that is what I did. And this one is also for oxygen first line that I did, which has less amount of sources. So then I prefer to use the with the highest number of sources, which is 1,596 number of sources. from 13,023 clusters. So finally, we decide the BPT of nitrogen 2 line that classify us to go further to study more about the properties of the AGNs in my statistical. Now we just see the distributions of the each of them. For example, one of them is the stellar mass distributions. Again, I divided all things into 3 redshift ranges, the low redshift at high redshift. The red one, what you see is the whole redshift. And this one is the stellar mass distribution. This one is the number of sources. This is for AGN. This is for Sy2. And this one is for LINERs. So as you see, the stellar mass of, we know the total mass of the galaxies that we have. So this one, what we see is most of them are located around here. The statistic will be seen at the table in the finals. So most of them are more massive. So this one is for, the green one is for high redshift and the blue one is for low redshift. So as I'm saying, the statistic will show us at high redshift, there will be a little more high or massive stellar mass, or the stellar mass will be increased. So that is what I see from my analysis. When you come to the Sy2, again, this is the whole sample that we have in the sources. This is the stellar mass. This is the number of sources. So I found like a few of them are in all redshift and at high redshift. The green one is at high redshift. They look like the same. So again, they will show us around here, which is a little bit at high redshift, the stellar mass is also increased. So this is also, we know the stellar mass of the LINERs is look like similar to the AGNs that were we discussed. So as I'm saying, the number of sources, it is a little bit increased. And again, here is stellar mass also increased when the redshift also increased. That means the green lines. So here is what we see from the diagrams. So I checked the 25%, the median 50%, the quartiles. The quartile, the 75% of this one is taking into account redshift trend, like I told you. So this was the median, so which is a little bit shown around here. And when you see at high redshift, so the stellar mass also a little bit increased. So that is what we expect from the local universe in this time. So this one is also for Sy2, and this one is for LINERs. So when you come to the Sy2, so at a little bit at high redshift, there will be a few changes, like a few increasing in the number of sources. So that means at high redshift, there will be massive or stellar mass will be increased. So this one is for LINERs. Basically, the LINERs and the AGNs look similar. So that is what we expect from the previous one. So the next one, what I did was I checked the Gband distribution. Though the Gband distribution, again, the stellar mass distribution was taken from the SDSS MJP of that catalog. So I didn't directly calculate it. So we just used from the SDSS DR8. So basically, the Gband magnitude of that the SDSS DR8 they calibrate was expected to be around 22, but due to the observational biases, due to many things that we have to, they have instrumentally problems and so on. So we found basically around this things. So they expect to be around 22, but we found around here. So again, this is for AGN samples, and this one is for Sy2, and this one is for LINERs. So as you see, As you see, most of them Gband distributions of the number of sources is around here. So we could see around 18. Around this is the Gband magnitude that we found. So as I told you, due to many things, and we can consider, so that is what we found in our analysis. So the next one is we see the redshift distributions, taking into account 3 redshift ranges. So as you see, the red one, this is the dot line of this one, will goes to in all redshift ranges. So this is the for all redshift ranges. So when you see the blue one comes from 0 up to this one, so we know that the completeness of the SDSS is very important. So we can see most of them are located around this redshift ranges. The number of sources is increased, but when you see at high redshift, this one, the green lines will go around this side. So what we see is when we increase the high redshift ranges, so we can increase the redshift ranges. So this is for AGNs. So when you come to this one is for Sy2. Sy2 will show us at high redshift. So there will be a loss of many sources. So we found most of our sources are found at high redshift ranges. So this is for LINERs. When you see the LINERs, so the number of sources will be look like similar to the AGNs, because we divided the agents into 2, the Sy2 and LINERs. So at high redshift, most of them are founded in this area. So we see the most of the sources are fainter. So this one is the star formation distributions. So this is a star formation rate, and this is the number of sources for AGNs. And when you see the AGNs, they are most of them are located in the low or quenching of star formation rate. But when you see around here at high redshift, you mean the green one will show us there will be few star formation is going on around here. That is what we see on these AGNs. So this one is for Sy2. So as you see, there is a few star formations going on around here, but most of them are, they didn't show us the star formation rate, so they will be quenching star formation rates. So this one is for LINERs. LINERs also have the same as with the AGN, so there will be a few star formation is going on around here. So most of them are again the quenching star formation rates. So we cannot have more star formation rates. So, but it is better when you see when you compare the Sy2 and the LINERs, it will have some changes. Now we come back to the next one. So this one is about distance from the cluster centers. So from the galactic center. So as you see, this is the AGNs. So the red one is for the whole sample of the AGNs having in all redshift ranges. And when you see the blue one is at low redshift ranges, and this one is for high redshift ranges, what we see is most of them are trying to close to the centers. So, but when you see there is some change around here, so which is what we expected. So there will be at high redshift, there will be at high redshift, most of the agents are a little bit far away from the clusters. So that is what we see. So when you see the Sy2, also most of them are, this is for low redshift ranges. At low redshift ranges, the Sy2 are trying to far away from the cluster centers. And this is for high redshift ranges. Most of them are located, try to close to the centers. And this is also what we see when we have at high redshift and at low redshift ranges. So there is a a little difference from the high redshift and low redshift ranges, but still at high redshift ranges. So there will be a little bit far away from the cluster centers. This is what we see from the diagrams. The next one is about the luminosity of the AGN sample that we have. So we found that most of the AGNs at high redshift are more luminous, around here, around 44 erg per second. And at low redshift, there will be a little change. They will go to this one. So there will be, again, it is high, but we have a little change that we see. So when we see the Sy2 we have also shows high luminosities around here, and this one is for low redshift ranges. So a little bit changes. The low redshift goes to around 44. 43.4, and for high redshift will be the statistic will goes to from 46.6 up to 44 points. So this one is for LINERs. LINERs will show us the same with the AGNs. So most of them are luminosities of having this around 44 erg per second. This one is for low redshift ranges. Yes, this one is a cluster richness distribution. So when we say the cluster richness, it means how many of them are in the galaxy clusters members or the groups. So we check our analysis is based on the two things, based on the cluster richness and based on the distance from the cluster richness. So as you see from the cluster richness and the number of sources. So this is the whole sample that we have, and when we see at low redshift and at high redshift, again, most of them are galaxies. They are found around here. So basically, we are working with the galaxy groups, not galaxy clusters, because most of them are located around here. So the statistics will show that most of them are in the galaxy groups. So again, this is also for works for Sy2. Sy2 will also show us most of the statistics are shows from 22 up to 60s or 50s. You can see most of them are located in here. So our clusters are mostly galaxy groups. So again, here is also the same as with this one. So we are basically working with the galaxy groups and the galaxy clusters. So we have a little more located on here, but most of them are founded in galaxy groups. Now we try to see the relationship between the cluster richness and the star formation rate. We see at low redshift within the two different colors. The low redshift is the red one, and the blue one is for high redshift ranges. So this will show us, again, as I might explain to you. So we are based on the cluster richness and distance from the cluster's richness. So we want to see the relationship between them. So what we see from this diagram is most of them are located around here in the galaxy groups, and they are mostly in the quenching star formation rate. So there will be a few star formation going on here, but that is what we expect from the local universe. So basically, we didn't find any correlation between the cluster richness and the star formation rates, because what we see here is most of them are located in the galaxy groups again, and they are located in the quenching star formation rates, or we don't have much star formation going on here, but there is a few. Most of them are founded on here. So we expect a little bit different, but we didn't find any correlation between them. So this will show us our AGNs are basically located in the galaxy groups. So it doesn't depend on the redshifts, because at a high redshift and even at low redshift, it doesn't show any difference for us. So this one is again, we try to see the cluster richness and the luminosities. So as we see from what we expect, the blues and the red dots are located around here, mostly in the galaxy groups, and this is most of them are distributed differently, so we cannot see any relationship between them. So we are not lucky to have any correlation between them. So we try to say that there is no relationship between the luminosity of the galaxies, the AGNs, and the cluster richness. So when you come to the relationship between the cluster richness and the stellar masses, so this is for low redshift and high redshift, right? So the distribution is different. So they become in different places. So we see them, most of them at high redshift. They are located at within massive. So the low redshift will goes to around here. So we cannot say that there is a clear or significant relationship cannot be seen. So there is no relationship between them. So when you see the next one is we try to see the relationship between the distance from the cluster centers and the luminosities. As you see, the distribution was comes to the red one within low redshift range and the high redshift range. They are located distributed in different places, so we cannot see any correlation between them. So again, this one is also the we expect to have some relationship between the high redshift and the low redshift ranges. They distributed like directly, so we cannot have clearly relationship between the clusters distance from the cluster center and the star formation rate. So this is also what we expect from the universe. So then I did was I tried to see the morphological classification. So we tried to identify the type of the galaxies, so elliptical, is a spiral, and uncertain using the galaxy zoos. Then what we see is all of the are located at high redshift range, and this one is for the blue one is for low redshift trend, this one is for high redshift trend, this is again for AGN, this is for Sy2, and this one is for LINERs. So this is what we have seen. Then we try to come to see some of the relationship between the cluster distance from the cluster center and the morphology of all the elliptical and the spiral and uncertain galaxies. So basically, most of them are located in the uncertain galaxies. So the number of the elliptical galaxy is a little bit high, so they are more try to be close to the centers. And the spiral galaxy will show little distributions over here. So the green one will show the spiral. And the uncertain is more, so that means we lost many sources. So this is what we see. So when we see the spiral galaxies, the Sy2 galaxy, sorry, so this is elliptical was more located in here, and this one is the spirals. So the elliptical will have a little bit try to be close to the centers, and this we lost many sources, which is uncertain. And the green one is the spiral galaxies, and as I was saying, the LINERs and the agents have similar properties. Now we just try to see the distance from the cluster centers and the number of sources. So this will show us, depending on the type of the elliptical, spiral, and uncertains. So this is at lower shift. So what we see is the elliptical will try to be more close to the center, and the spiral is also trying to the close to the center, but elliptical is more. So and most of them are uncertain galaxies, which is located on here, and this is what we see from our analysis. This one is the distance from the cluster center in relation to the morphological type of the galaxies. The red one, the elliptical, the spiral, and the uncertains. So we see most of them are closest to the centers, and some of them are try to close to the center, but the uncertains are going to be a little far away from the cluster centers. So this looks like similar to the LINERs ones. So the Seifert has shown different properties, which is having ellipticals are trying to have some correlation with our relation to the close to the centers. And then the other one is the Seifert are basically far away from the cluster centers. So here is the based on the type of the galaxy, the morphological type of the galaxies, having on redshift ranges, the elliptical, the spiral, the elliptical galaxies, the Seifert, and the LINERs. So what we see here is most of our galaxies are ascertained and classified as well as, and most of them are going to have elliptical galaxies, which is located around here. So this is basically located in the galaxy groups. So we basically work on the galaxy groups. So this is what we see from the diagrams. So when we see the cluster richness in relation to the morphologies, depending at basically at low redshift. So we say that most of them are located in the galaxy groups, and the number of sources will be a little high, which is the uncertain one is high. So elliptical is a little bit high, and the spiral will show this one. So this is a distribution that we see. So this is what we see from the diagram. This one is also for the cluster richness in relation to the morphologies at high redshift ranges. So this one is for elliptical. This one is for uncertain galaxies, and this one, the red one, is for elliptical galaxies, and this one is for Seifert galaxies. So most of them are uncertain or unclassified galaxies. So we have few number of elliptical galaxies. We see the statistics at the finals, and the spirals are a little bit. So what we see here is elliptical galaxies are more earlier type of the galaxies, so we know that they are trying to close to the centers, and mostly found in our analysis in the galaxy groups. So this is what we see for Seifert, and this one is for LINERs. So the number of sources for LINERs and for AGNs look like similar, but the number of sources will be different. Again, most of in all analysis, the uncertain galaxies are dominated, and the number of elliptical galaxies is a little higher than the spiral galaxies, as you see from the diagrams. Here is the summarized table that we see from our total analysis, taking into account the quartiles, median, and quartiles for AGNs, for LINERs, and for Seifert, taking into account all the redshift, and this one is for a low redshift, and this one is for high redshift ranges. So this is what we found in our analysis for a median, for even for AGN, the star formation rate was around here. So we means most of them are not have star formation rate. So the stellar mass, they will show us high or increasing in the stellar masses. The redshift is around here. That is the distance from the cluster center. Here is the luminosity. Here is the Gband of the AGNs. And this is all the analysis for AGNs. This one is for LINERs, and this one is for Seifert. And this is what we did. And finally, we conclude with what we see from our analysis. Our LINERs are more found to be hosted by more massive galaxies than Seyffert's, and mainly elliptical galaxies, and Seyffert's are more hosted by the spiral galaxies. And we expect the relationship to be between the cluster richness and distance from the cluster centers, but we didn't find any correlation between them. So the statistics will show us what we expect from the properties or the type of the galaxies, the morphological type. That is what we know from our local galaxies. So this will give us, just in order to say that our result may suggest that the environment doesn't seem to affect significantly the AGN properties in the galaxy groups and the clusters. So that is all. Thank you.
Thank you, Meron. Very interesting. If there are questions, please ask on the chat or raise your hand. I have a question for you, if you, because
okay.
I have seen that you have a lot of galaxies with the double classification.
Yes.
And this is because you use the galaxy zoo, but have you checked if this is due to the fact that maybe there are features connected with the activity of the galaxy or not? Because it's strange to me to have so many objects with uncertain classification.
Yes, yes, yes. So I was checking how how I use the galaxies. Basically, the redMaPPer galaxies, which is the morphological type, which is galaxy zoos, and I checked them. There is some observational bias in so many things, but I didn't go details how it works. But this work is my first and my initial work. Maybe for the future I will go further details how this will happen, because the work is still ongoing.
Yes, okay, because it's really strange, because I understand that you have many AGN in groups, it's okay, it's what we expect, but this large number of doubtful classification is puzzling to me, because it's strange, but
Yes.
could be, it could be a result, okay.
Yes.
Any other questions? And only a curiosity, why you decided to study astronomy?
Basically, when I grow up, I like to watch the sky, so it was interested. So I have, when I asked my mom, she told me that I have a lot of more questions about. I like to watch the sky, just the night, the sky. So on the dark in the night, so they just try to give me the chance to appreciate me, to work with my interest within science. So I get the chance to have an opportunity to learn about, to have an awareness about astronomies, and this will give us interested for me. So I get the chance to come from another place to learn astronomies in here. So we have a few women in here, so basically a few, 3 or 4. So in astronomy, we don't have much awareness about astronomy. So even I work for the many activities in my universities, in different outreach activities. So this will give us to know a lot more about where does we come from. So we have a lot more questions are still open, right? So that this will give us maybe, if I get the chance to work to answer one of these open questions. So this will give us huge opportunities for me to know a lot more about the universe.
Okay, very well, good. Any other question? If no, we thanks again, Meron, and we wait you for the next one in 1 month for the last one.
Okay, thank you very much for all of you.
Okay, bye-bye.
Bye-bye.